So I'm going to create an interface called product DAO and two implementations of the same called dummy product DAO as well as JDBC product DAO. For this demonstration, we're going to use annotation based configuration for Spring Container, and then we're going to write a public static void main program to test out everything. Let's go to Eclipse, where I have few options here that says create a Maven project. If you don't see that, no problem. You can always go to File, New Maven Project. If you still don't see here, that's probably because of the perspective. Currently, I am in Java EE perspective here. If you are not seeing the Java EE perspective, you can always click this button. And notice that Java EE is the default. And if you don't see Java EE, then you have a wrong version of Eclipse. Go ahead and download the Java EE Eclipse and then come back again. Let me create a new Maven project. And the reason we are going for Maven is it is a fantastic tool for managing all your Java library dependencies. And the very first thing that we want to do is to create a simple project by skipping archetype selection. Click on the next button. Maven has a repository of lots of projects where you can make your project part of that repository. And to organize projects properly, Maven expects you to give group ID, which typically represents your organization, and artifact ID, which represents the kind of project that you're working on. For example, if you're part of Apache Software Foundation, your group ID would be org.apache. If you're from Microsoft, you may have com.microsoft. Since my website is vinod.co, a typical group ID would be co.vinod, and artifact ID would be name of the project that you would be working with. Now currently I'm creating a project for learning the basics of Spring, so I'm going to call it as Spring-Basics. And the packaging can be a jar, var, or pom. For now, we are not working with web applications, so we're going to simply create a jar project. Later, we will also be using a var project, which is web archive. You can give additional name and description. For example, this is going to be a Spring Basics. There's no other next option. You can click on finish and the project gets created. The project also has one file here called pom.xml, which is project object model XML. Let's open the same, and that brings up a XML file, but you can see a GUI version of the same here. At the bottom, there's a tab here for overview, dependencies, dependency hierarchy, etc. At this time, since our pom.xml is pretty much empty, there's nothing over here. One other thing that you can observe here is for the project, when we created using new Maven project, Eclipse has a plugin called M2E plugin, which creates this entire project. But somehow it uses a Java version 1.5. If you go to project properties, Java build path, under libraries, you will see that JRA system library, it has taken it as J2SE 1.5. One thing we can do is we can just double click this to choose a different version of Java like this. But I'll not be doing that primarily because each time you do a Maven update by right click on your project, and then there is an option called Maven Update Project. It will be reset to 1.5. So to permanently make this as 1.5, we will be specifying here a plugin. So we have an option called Build. Under Build, you have something called Plugins. And one other plugin that we would be adding is the compiler plugin, which specifies that the Java version is 1.8. So we'll have to add a plugin, and the plugin has something called Artifact ID, and this is Maven compiler plugin. And the configuration for the same is where we say that the source code version is supposed to be 1.8, and then target version is also 1.8. And now that I've done this, let me save this file. And at this time, you can see there are a couple of errors over here. There's one is it says Java runtime environment compiler compliance problem. Let's update our project. So right click on this project, do a Maven update project. I click on OK, and you can see that the errors are gone. Plus, I can also go to project properties, and you can see under Java build path libraries, it has taken Java SE 1.8 automatically. So this is a one-time setup for the project, so let's keep this as it is. And now let's add a couple of libraries which are required for working with Spring. So for this, open a new Chrome tab and then go to a website called mvnrepository.com, which is also called Maven Central, where all the libraries required for your Java projects would be available. And we will heavily depend on this particular repository to get the required libraries. And the libraries required, you simply search by keyword. For example, if I type here Spring, I should be able to get lots of libraries related to the Spring. Typically, one library will have dependency on another one, and that probably may have dependency on another one. Maven can resolve all those dependencies and download all the necessary jar files. For example, if I select this Spring context and choose an appropriate version, let's select the latest release, which is released in December 2019, a month back. So I'm going to select this, and you can see there is an XML for Maven, there's Gradle, SBT, and a couple of other dependency management tools. I'm going to click on this, and that automatically copies to your clipboard. No need to select and press Ctrl C, but it gets automatically copied. So I come back to my Maven pom.xml, and after the build, I'm going to add here a section called Dependencies, and then I just paste it. Press Command Shift F on Mac, Control Shift F on Windows and Linux, and that gets formatted. So once again, if you see that the dependency here represents a group ID org.spring framework. So somewhere there will be a folder called org/spring framework /spring context /5.2.2.release, and inside that there will be a jar file. Note that I have not saved the file yet, but as soon as I save the file, you will start seeing some download activity at the right bottom of your Eclipse. In my case, I've used this version of Spring earlier, so it is already available locally, and you'll see that there'll be a new entry here called Maven Dependencies, and that might come quickly in my case because I have used this earlier. So as soon as I save it, you can see in a few seconds you should see Maven Dependencies, and when you expand that, you will see a couple of jars. This is the one that we have specified here, but if you look at the dependency hierarchy tab under pom.xml, you'll see that the Spring context is what we mentioned, but that has a dependency on Spring AOP, Spring Beans, Spring Core, Spring Expression. Spring AOP has a dependency on Spring Beans, Spring Core, and Spring Core has a dependency on Spring JCL, and because of that, you see all the jars over here. Now that we got the Spring libraries, let's bring our actual application, which is this. We want to create a product DAO interface with a couple of implementations. For now, both the dummy implementation as well as the JDBC implementation, let's return some hard-coded values, and later in the subsequent videos, we will get the actual data from the database tables. So let's go to our code. Let's close this pom.xml. Let's right click on src main Java. This is where all your Java files go. And this is where you may want to put your XML or properties files, etc. over here. And these are related to test. In case if you're writing some JUnit test cases, that's going to go in here. And the resources corresponding to your test would go to this location. In any case, I'm going to right click on this src main Java, new interface. And as a good practice, let's give the proper package names, even if it's lengthier. Let's give it as co.vinod.dao, because this interface is a product DAO, which is supposed to deal with the database objects. And the name of the interface is product DAO. Press enter. Let me increase the font size a bit further. Typically, this must have something like CRUD operations and queries. But for the time being, let's add only a single query function, which is supposed to return a count of all the products that we have. And in general, as a good practice, every DAO function must throw a DAO exception, which is supposed to be a user-defined class. For the time being, let's simply put a semicolon here saying that whenever you call this function, you're going to get a long, which is the count of products that you have in your database tables. Let's go and create two implementations for this. One is a class. Let's call this as dummy product DAO. Now, if you observe the name, there are two parts to that. Number one says, how does this implement? And the number two is, what does it implement? So in this case, it's a dummy implementation of a interface called product DAO. So let's add the interface product DAO here and click on finish. We get this basic functionality. Let's get rid of this to do. You can press Command D on Mac, Control D on Windows to delete the line. This being a dummy product DAO, let's return 0 as its value. Let's save this. Now I want to create one more class, but instead of creating a new class, I can click on this, copy this by pressing Command C and paste it using Command V, Control C, Control V for Windows. This will bring a dialog box saying that the name conflicts, so do you want to rename? And this time I want to create a new file called JDBC product DAO. I click on OK, and you can see that we got another class. Double click that to open. And for the time being, let's return a value of 100, a hard-coded value, because we don't want to really work with the database at this point in time. We just want to make sure that we have a product DAO and we have two implementations, and Spring can give me an object of either one of them depending on the configuration that we have. Let's go back and create a configuration file. For that, I'm going to right click on this package and I say new class. Since this is about configuration, let's change the package to CFG or config or whatever you feel like. And then let's call this as app config. In the course of this training, we're going to write different configuration files. So let's name them as app config 1, 2, 3, etc. Let's click finish. Eclipse automatically creates a new package for me, and inside that we have this class. The very first thing that you want to give here is an annotation called @configuration, and you can import that by pressing Control space, or you can press Command Shift O on Mac, Control Shift O on Windows, and that actually organizes our packages. At this point in time, this annotation @configuration doesn't add any value. So even if you don't have this, your application would still work. But as we go forward, when we start working with aspect-oriented programming or transaction management or security, without @configuration, your application may not work. So since this being a class, and inside a class you typically declare variables and functions, the configuration class expects you to write functions that return bean objects. For example, I can write a function here called public dummy product DAO. This is the return type. Let's call it as dummy DAO, where it returns a new dummy product DAO object like this. In order for Spring to make sense, you have to annotate this with @bean. Once again, to import, I'm going to press Command Shift O or Control Shift O on Windows. And I'll also write another function that returns a JDBC product DAO. Let's call it as JDBC DAO and return new JDBC product DAO like this. So if you do not annotate this function with @bean, Spring doesn't care about this function at all. But if you add @bean, Spring gives a different treatment to this function. We'll see that in a few minutes time. But now our configuration is ready. So we supply this class information to Spring. Spring automatically calls all the functions that are annotated as @bean. And this is where a concept of inversion of control also comes into picture, where we do not call this function, but Spring automatically calls this function when it feels necessary. Let's go back to our picture to have a clear understanding of what we have done so far. So we have this product DAO interface, we have this dummy implementation, we have a JDBC implementation, and we have this annotation based configuration. Now all we have to do is to go to the app.java, where we want to create Spring container making use of this annotation based configuration. And then we ask Spring that, hey, I depend on a product DAO, give me an instance of product DAO. So let's go back to Eclipse. Create a new Java class, which is a program. Let's right click and then say new class. Since this is a program, let's put the same in a package called programs. And let's call it as P01 get product count. We'll also add a public static void main and say finish. So we do get this particular program. Let's minimize this section. Let's get rid of this to do by pressing Command D on Mac, Control D on Windows. And this is where we want to say that our application depends on product DAO. So let's create a variable of that type. Let's call this as our dependency. But in order to provide the dependency, we need the Spring container. So this is what we want. A Spring container is represented by an interface called as application context. So if you press Command Shift H or Control Shift H on Windows, you get this called open type hierarchy, and then you type whatever the data type that you're looking for. I'm going to type as APPLCON, and you can see you get applet context, application context. This is what I'm looking for. It's an interface, and that interface has got few implementations. Application context is an interface. There is a sub interface called configurable application context. If you expand that, you will see that there is an abstract class, there's another abstract class, there's another abstract class. But if you see somewhere down the line, you have two files here or two classes called class path XML application context and file system XML application context. So basically what this represents is it represents an application context using an XML configuration found in the class path. Likewise, this is an application context, meaning it's a Spring container which is based on an XML file which is found in the file system. Since we are not using XML, these two classes are of no use to us. Let's expand this one, generic application context, and you will see that there are few implementations here. The number one is the annotation config application context. That is exactly what we want. So we want to create an application context or a Spring container using annotation configuration. If you add more libraries, for example, Spring Web Modules, then you will get more such Spring containers also. In other words, an object of any of these classes represents our Spring container. Since we're going to use this annotation config application context, let's go here, define a variable representing the Spring container, and that's done by using annotation config application context. You can see that I'm typing the first letter of each word of the class and then press Control space. You will see that you get an annotation config application context. Let's call it as CTX. Now you need to initialize that, and this is where we get an object of Spring container, and you say CTX equals to new annotation config application context. You can see that there are different types of constructors here. The one that I'm looking for is this, where I can supply one or more classes that are configuration classes. We created something called appconfig1 here. We're going to supply that here by typing AC1 control space dot class. So now we have here a Spring container that is defined based on a configuration here. Let's full screen our editor, put a semicolon here. Now we have this Spring container. You also see a warning here because creating a new Spring container has some resources that are opened. Now if you don't close this context, there is a probable resource leak. So somewhere at the end, you make sure that ctx.close is called, and now the warning is gone. Now the Spring container is going to read the beans defined in this appconfig class, and in the appconfig class we have defined two beans. So that means at this point in time, Spring is going to collect the return value from these two functions, because Spring is going to call these two functions and then keeps that in the memory. So at this time, if you run the program, our application creates a JVM, which is the area where we have all our objects. And there is this CTX, which is a reference variable. This particular section, when we say new annotation config application context, creates a Spring container. Now the Spring container is like any other containers like ArrayList or HashMap, where it maintains objects. But this time we supplied a configuration class called appconfig1. The appconfig1 is right here. So Spring instantiates appconfig1 first, and using that object, it's going to call every function that is annotated as @bean. So which means it's going to call this function and collects this return value called dummy product DAO. You can think of Spring container is almost like a hash map where there is a key, and the key will be the name of the function or a bean name that you can specify over here. So by default it's the function name. So the name dummy DAO refers to an object of dummy product DAO. So what we have here is an object, and let me call it as dummy here, and another object called JDBC. Of course, it's called dummy DAO and JDBC DAO, and then comes back over here. And that newly constructed Spring container is assigned to CTX. So our CTX refers to this object at this time. So I can say that this is our Spring container. But now that we have the Spring container, we also have a variable called DAO, which is again another reference variable. That reference variable, I can say here DAO equals to ctx.getBean, and then I can supply either the data type, like simply say give me a product DAO. But since in our case there are two product DAO objects, Spring gets confused, there's an ambiguity. So we can supply a name of the bean, dummy DAO or JDBC DAO. But in which case it's going to return a generic object. You may have to do a casting. But in Spring 3 onwards, you can supply the name of the bean as well as the required data type. This is what we want to use. So the name is going to be dummy DAO and the required type is product DAO.class. So the casting not required. And now that I have the DAO, we can check what kind of object it is referring to. So I'll say DAO is an instance of, and then say DAO.getClass.getName. And then I can also say here there are DAO.count products. And that's the whole idea. We want to get the product count. So let's save this and run the application. So before running the application, let's have a look at what actually we have done. So we have created an app. This is our program right now. We created a Spring container. So our application depends on a Spring container. The Spring container has manufactured objects of dummy and JDBC implementations. And those are defined in the annotation based configuration. And our application simply depends on the product DAO and doesn't depend on either of them at the compile time. So if you go back over here, you see that we have not used any imports related to dummy product DAO or JDBC product DAO. So this is what actually we have achieved, 100% loose coupling. Our application depends on an interface type, not on an implementation. Of course, at the runtime, we need an implementation, but that is resolved by the Spring container. So since the Spring container is acting as a factory here, to factory we supply something called Discriminator over here. And this defines what kind of implementation currently we are interested in. So if I run this right now, you're going to say there are 0 products and DAO is an instance of dummy product DAO. But if I change this to JDBC over here and then run the same, notice that I've not saved the file. So it's going to ask me, do you want to save? There's a checkbox that says always save resources so that we don't run uncompiled files. So when I say OK, we're going to get a different instance this time. It's an instance of JDBC product DAO and there are 100 products. Of course, this is a hard-coded value, but we are getting an object of a different kind and method from that object. One other thing that you can also check out is that at this time, when we supplied the app config 1, let's put a constructor over here. You can press Control space. You'll see that there is a constructor. Delete this by pressing Command D or Control D, and then let's put a system.out.println app config 1 instantiated. So we'll see that at this particular very moment, you will see that the app config 1 gets instantiated, and not only that, these functions are also going to be called. So let me copy this and paste over here. Let's say dummy DAO called. Let's put a message saying that app config 1 dummy DAO called, and the other one we'll put here as JDBC DAO called, so that we know that with @bean this specific function would be called. So let's go and run the application. You will see that there is a sequence that says app config 1 instantiated, dummy DAO called, then JDBC DAO called. All those things are called right here itself. For example, if I put some kind of a marker over here, You will see that before printing this line, you would see those messages. So let's run the application again. You can see that before the line, app-config1 is instantiated, dummy DAO called, JDBC DAO called, and then we are getting this. However, if I go and remove this or comment this part, this function is just an ordinary function and Spring doesn't care about this. Spring will never call this function. You may have to call this function. Whereas Spring is having no problem in calling this function because it has been marked as a bean. So let's save this, run the program again, and see that the dummy product DAO is never called. Let's get rid of this comment, save this, go back to the picture. And this is the first aspect of Spring, which is the Spring as a factory of beans is what we have seen. Spring manufactures and collects all the beans and then keeps it in the container. Whenever we want, we are only going to ask for the same.